Okay, so you had some trouble with solving, is that right?
Yes.
Okay. What's an example? Which problem were you looking at?
Number 3.
Okay, I'm not going to do the exact one that you're assigned. I'll do something similar. Okay, solving equations. All right. Okay, I see it here. This is number 3. Okay, all right, I'll pull something similar here. X squared plus 11 and x squared minus 6. All right, so how would you start this? What did we do yesterday? Remember our first steps?
I would try to find out which one has the highest exponent.
That's true, right? So how many solutions are we expecting?
4.
Yeah. Okay, so we know there's 4 solutions. Good. All right, so how do we go about finding those solutions?
Always subtract x every subtract the x.
Well, let's see. What did we do from yesterday? How do we start this problem?
Square root it.
Well, before that, we want to do what? We want to set each parentheses equal to what?
To 0.
To 0, right? We want each to be a separate problem. Because we have to think of this as 2 separate problems, and then we'll solve them individually. Okay, so here we expect 2 solutions, and here we expect two more solutions. Okay, what's next?
Next, you're gonna subtract 11 from subtract 11.
Okay.
And then
Next.
Next, you're gonna subtract. Add 6.
Well, let's finish this first, and then we can. Let's solve x. Okay, square root. Okay, what do you notice?
It's an odd number.
Okay. But what type of a solution are we looking at? Can you tell?
Plus negative.
Okay. Can you be more specific?
So it's going to be an imaginary number?
You're right, imaginary solution. Okay, so the way we write the solution, also How many imaginary solutions are we going to be getting here?
One.
Well, we see x squared here, right?
Yep.
So what does that tell you?
Oh, it's 2.
2, right? So where's that second solution going to come from?
The x squared.
Okay, what happens? So we get x equals square root of -11. What's the other solution?
X square root of 11.
So whenever we take the square root, there's always something that pops up in front. Do you remember what happens out here?
A plus and negative sign.
Yeah. That means these are two separate solutions here. So there's a positive square root of -11, and there's also a negative square root of -11. Right. Does that make sense? We have two separate solutions here.
Mm-hmm.
And then there's a special way that we deal with this negative. We push this out in front and we give it the fact, you say it's imaginary, so we have a special symbol to indicate that it's imaginary. So this negative comes out and we're gonna turn it into an I. So we have x equals I root 11. So basically we're transforming this negative into something that we can see is telling us that it's an imaginary number. Okay. Does that make sense?
Yep.
Okay. How about this one? So there's 2 here, right? We know there's 4 total. We have 2.
So the other side, you gonna add 6.
Mm-hmm.
And then you gonna square root it.
Mm-hmm.
Then next, the square root of 6 is gonna be 3, right?
Well, I don't think square root of 6 is going to be a whole number. Basically, this is saying what 2 numbers multiplied together will give me 6. Well, 3 times 3 is already 9.
Oh, it's 2.
2 times 2 is 4. So in order to get 6, it has to be somewhere between 2 and 3, which is not going to be a whole number. Probably like 2.3 or something. So if it's not a whole number, you can leave it like this. You don't have to, I mean, you can plug in the calculator. It's like probably give you like 2.3 or something. But if you know it's not a perfect square, then you can leave it alone.
Okay.
But so what's x equal to?
X equals 6.
Square root of 6, right?
Right.
And do we have another solution, or is that it?
That's it.
That's it? Well, I have 1, 2, 3 solution. I should be.
Oh yeah, it's 4. So x equals square root of -6.
No, not negative. Well, okay. Yeah, actually, there is a negative, but where's the negative going to go?
The it's -6.
So what happens whenever we take the square root? Something's going to pop up in front.
The plus and negative sign.
Mm-hmm. So how do we write that out? So this will be the same thing as the positive root 6. So the other solution is going to be what?
plus a -6.
We just cover up the positive and just make it just -6. So this is the positive version here. Sometimes if it's positive, we leave it out. We don't have to put a plus there because they mean the same thing. Does that make sense?
Okay, I understand.
So we have, this is like 2.23, there's -2.23, and then we have two imaginary solutions. So there we have it, 4 solutions here. We got 2 imaginary, 2 real. They add up to be 4.
Okay.
Okay. All right, so hopefully that'll help you get through part A problems.
Okay.
Okay, so here's a part C. It's a little bit more complicated because there's something called difference of cubes or sum of cubes. So let me show you what that looks like. Okay, so let's say I had x to the 4th plus 64x equals 0. Okay, first thing we do is we take out the GCF. What's the common factor that we can take out here?
Common factor.
What's shared between these two terms?
X.
X. I can take an x out, yeah. So that leaves me with, so if I take an x away from this guy, what am I left with?
X3 squared.
X to the 3rd.
X to the 3rd plus 63. I mean plus 64.
Yeah, 64, yeah. And there's something special about these numbers here. These are what we call perfect cubes. Perfect cubes means that there is a number, if I multiply the same number 3 times, I can get to 64. And that number is 4. Because 4 times 4 times 4 is 64. So we call this a perfect cube. So if it's a perfect cube, we can write it in this form. And the nice thing about this form is that we can fit it into something called the sum of cubes. So here's the property, here's the rule that we're going to be using.
Where you get the 4 squared?
You mean the 4 cubed?
Yeah.
Because 64 is same thing as 4 times 4 times 4. And if I multiply 4 3 times together, instead of writing it 4 times 4 times 4, I can write it as 4 to the 3rd power. Okay. It just looks a little bit cleaner.
All right.
Okay, so there's a special way that we can split this up. And it looks like this. It's a plus b times a squared minus ab plus b squared. So there's a formula there. It's called the sum of cubes. So we're going to break this x cubed plus 4 cubed into parentheses using this rule here. So what we're going to do is we're going to treat the x as the a value, and we'll treat the 4 as the b value. Okay, this x is going to stay. It's not going to go anywhere. So x first. I'm just following the rule here. The rule says a plus b. So what's my a and b going to be?
X cubed. 4 cubed.
Just the x. We're going to ignore the cube is the original statement, but then we only want the a plus b. So we only want the x plus 4. Okay. All right. What's a squared going to be?
A squared.
Say it again.
You said a squared?
What's a squared going to be?
X.
X.
Cube.
X squared.
Oh, x squared.
Yeah. So right now, ignore the cube here because it's part of the statement, but it doesn't show up here, right? The cube is just, the A is just the X and the B is just the 4. Minus, what's next?
X again.
Mm-hmm.
And then 4.
And 4. So we say 4x. You can say x4, but usually we put the number in front of the variable if they're together. Plus.
Plus 4 squared. I mean 4 cubed.
No, 4 squared, right? There's no cube, right?
Squared.
Just a square.
All right, 4 squared.
Okay, so now we can solve. Okay. How many solutions do you expect out of this?
5.
When there's no parentheses, we only look at the highest exponent. If there is parentheses, you can add the exponent. So this is 1 plus 3, which is 4. So you can look at it here or you can look at it here, but it's either way, it's going to be 4. So there's one solution, another solution, and then 2 more solutions coming from there. Okay, so this is easy. X equals 0, that's already done for us. That's one solution. X plus 4 equals 0.
X minus 4.
X equals negative 4. Yeah, make sure you don't say X minus 4 because that's not the same thing, right? We got to subtract 4 and we got to leave that equal sign there. And this is something, it's not going to factor. This is something that we got to use quadratic formula for. Have you seen quadratic formula?
Yes.
Okay, we got to apply that. Okay. So do you know what the A, B, and C values are that we're going to insert into the formula?
A is 4x, right?
Actually, A is the number attached to the x squared. So it's going to take on, it's going to look like this. It's going to be ax squared plus bx plus c. So the a is the number in front of the x squared, the b is the number in front of the x, and the c is by itself, is the constant.
So A is x squared.
A is the number in front of the x squared.
So it's 4 squared? I mean, no, I'm not sure. 4x?
You don't see it, but it's hiding.
1?
Do you know what numbers here? Yeah, it's 1. If you don't see a number, it's just going to be a 1. Does that make sense?
Yeah, right.
Okay. What's the b value?
4x.
Actually, the b is just the number in front of the x.
16.
What's in front of the x? Or what's
4?
Close. Negative 4.
It's negative 4.
Does that make sense? Yeah. And what's the c value?
16.
Yeah. All right, so we have everything that we need. Insert into the formula here. All right, what does that look like?
Minus b squared. Minus b plus.
What's the b value?
Negative 4.
There's another negative here, so what's going to happen there?
It's going to be a positive.
Yeah.
Square root of that b.
That's b, yeah.
So it's negative 4 squared.
which is
That's -4 squared.
You know what -4 squared turns into?
16.
Minus 4 times
AC 17. I mean, one times 16.
yeah, all over
2 -4.
Where'd you get the -4 from?
That's my bad. 2 and negative. I mean 2 and 1.
Which is 2. Yeah. Okay, we clean this up here. 16 minus 64. I think it's going to end up being a negative number, which is -48. So we have 4 plus or minus square root of -48 over 2. This is an imaginary number, but we can just pull that negative out in front and call it an I. So you see that plus or minus there? That means there's 2 solutions here. So we have 1, 2, 3, 4. 4 solutions.
Okay.
Right, so that's how we can handle the sum of cubes. So you'll see something that looks like this. Okay, and then there's also another type, which is 4 terms here. Okay, so let me show you how to deal with 4 terms. Okay, you see how there are 4 terms here? So if you see 4 terms, you want to factor, but the way you deal with factoring with 4 terms is you split it up into 2 problems. We're going to take the common factor for each of these separately. So we'll ignore the last 2, just look at the first 2. What's the greatest common factor out of the first 2 terms?
The greatest common factor out of
What's shared between these 2 terms?
X.
How many?
5. I mean 3.
Okay, so let's say this guy has 3 x's, this guy has 2 x's. What's the most that you can take from both and be fair?
1.
This guy has 3. This guy has 2. What's the most that you can take from both?
2.
Yeah, 2, right? So that's the greatest common factor.
So it's only 2x. X minus
just x, right? X minus
2x.
Well, you already took 2 x's from this guy.
Yeah, so it's just 2?
Just 2. All right. Okay, how about this? What's GCF here?
Greatest common factor is 8, right?
What's the largest number that can multiply into 4 and 8?
4?
Yeah, 4, yeah. So we're going to take a -4 out. But then if you're dividing by -4, that gives me x. If I'm dividing 8 by -4, I get -2. So here's the thing. Do you see anything that is, you see any patterns between what we have here?
X minus 2.
Yeah, there's a shared x minus 2, right? So with that shared x minus 2, we're going to imagine these are two separate things, and we're going to take x minus 2 from both these guys. Okay, so we're going to take x minus 2 from both of these guys. So if I take an x minus 2 from both of these, then if I remove them, then the only thing left is x squared minus 4. And if I take x minus 2 out, then the non-shared term is going to be in their own space. Okay. So greatest common factor for each separate terms. Once you're always going to get parentheses that match, just take the parentheses out, and then the non-parentheses will get their own parentheses.
Okay.
Okay, how many solutions do we expect out of this equation?
3.
Yeah. And also we can count from the parentheses, right? There's 1x here, there's 2x here. We know there's 3 total. Okay.
You gonna add 2?
Mm-hmm. X equals
positive 2.
Mm-hmm.
You gonna add 4?
Mm-hmm.
X equals positive 4.
X squared equals 4. What's next?
You going to square root it?
Mm-hmm.
X equals 2.
Mm-hmm. Is that it?
No, because it's another X, right?
Mm-hmm.
X equals X equals plus minus 2.
Well, we already have the plus here.
Oh, it's negative 2.
Yeah. So if you ever see plus or minus, that's just because someone wants to be lazy and they don't want to write this out twice. That's all it means. It doesn't mean something different. It's just because of laziness.
Can you put plus or minus?
You could. You can say x equals plus or minus 2. But sometimes I tell students to write them out separately because sometimes students get confused. They look at this, they think it's something different, but it's just because, they didn't want to write it out twice, so they just leave it like that. But this is more clear, right? This is, if you don't know what's going on, that looks confusing. Okay, 3 solutions, just like what we suspected.
All right.
Okay, so I think that should help you out.
Yeah, it should. Thank you.
All right, so hopefully you can submit the project and I can move you forward. Okay.
Okay, thank you.
All right, take care, guys. Bye.
You too.